What are you saying? What shape does this make?
Triangle.
Right triangle. How do you find the length of a hypotenuse of a right triangle?
A squared plus b squared
Equals c squared. So the magnitude of A is going to wind up being the square root of negative 3 squared plus 4 squared.
Yeah, 4 squares.
Wait, is it going to be like
what?
5 or something?
This is when you solve the Pythagorean theorem for the hypotenuse. You always wind up taking the square root of A squared plus B squared.
Wouldn't the square root cancel
Pythagorean
the...
theorem.
Mr. B, is it going to end up as 5, like the 3, 4, 5 triple?
It is going to be a 3, 4, 5 triple. Good call. Alba, what have I said about exponents when there's a plus sign in the middle?
Oh, that wasn't me.
There was another girl in here with a Spanish accent.
Yeah.
All right, so A squared plus B squared equals C squared. Take the square root of both sides. It's going to be that. It is going to wind up equaling 5. Oh, there's another bit of notation your book uses.
Couldn't you use the distance formula?
This is the distance formula, really. Distance formula at the origin is going to be negative 3 minus 0, 4 minus 0. But yes, you can use the distance formula.
Yay.
Distance formula is really just a rewriting of the Pythagorean
Except I
theorem.
forgot it, so
All right, Pythagorean theorem.
I'll ask our geometry teacher, Mrs. Kalalaki.
Thank you. Yes, she'll appreciate that.
Lucky.
Okay, now. Oh, guys, one other bit of
She looks like a Kalalaki.
stop. One other bit of notation that you guys need to know. If your physics book is just talking about the x part of the vector, just the x part, it's going to call that a sub x, and that in this case would be negative 3. It's going to call the y part, the up and down part, a sub y. So there's a lot of notation going on here. You got i's, you got j's, you got a sub x, a sub y. They all mean slightly different things. Okay? So you find the magnitude is 5. How are we going to find the direction of this? How are we going to find the direction of this? I'll give you a hint. I want the direction in this case described in a form of a standard angle on the unit circle. So I want the angle from 0 degrees here up to this vector. There's 2 ways to do this.
We can SOHCAHTOA it up.
There's 12 ways to do it.
SOHCAHTOA.
SOHCAHTOA gives you ratios when you know angles.
That
No,
looks like
that
looks like 135.
Angle at the vertex.
So you want to know this angle down here?
Yeah, and then
Looks like
subtract
135.
it from 180.
That's an excellent strategy. How do you, if you know these 3 lengths, if you're looking at a triangle, I'll draw it over here.
So the sine of theta would be
I'll draw it right.
4 over 5.
Okay, so that's 3, 4, 5. This, Ramsey says the sine of
Ramsey
theta
Punjab.
will be 4 over 5. Is he correct?
I believe so.
Okay, he believes so. I think so too.
Okay.
If the sine of theta is 4 over 5, how do you find theta?
You plug it into your calculator, then
Yep.
subtract that answer, 180 minus that answer.
What do you plug into your calculator?
Sine of theta equals the anti-sign.
The anti-sign. I like that. The inverse sign.
Isn't it the sino?
Oh my god, everything's coming together.
Your calculator has a button of inverse sign. It's
Yeah.
got a little -1 there.
Right.
Anti.
How did Mr.
Arc
Singer
sign?
say it?
The
Arc
angle
sine.
of sine is.
Yeah.
So Mr. Singer is Mr.
Mr.
Yeah, I can say it. He works here,
Kantar?
Mr. Singer.
Mr.
Kantar.
Kantar.
Yes. So, all right. He works here. We can use his name. All right. What is the arc sine of 4/5? You pull out your calculator.
53 degrees.
53 degrees. So this is 53 degrees. So what's my standard angle? My reference angle is 53 degrees.
127.
127.
That's the direction?
Yep. So this would be a magnitude. The magnitude to 4 parallel lines, 2 on either side of that,
And what's the direction?
equals 5, and the direction equals 127 degrees.
How's that a direction?
And well, you got to know that we're all talking about. Well, basically, I have to agree that for this unit, we're going to talk about the Cartesian coordinate plane with 0 as an angle. Now, the word problems. Of course, this course is all word problems. The word problem is going to be phrased differently sometimes. We might talk about like a force pulling on a barge, and then we would say like the question might say how many degrees west of north is the barge moving or something.
Wait, west of north?
Yeah, it might get tricky. You might have to think about it. We're like north, or it might just say like
How do you get west of north?
West
So
over
north is the y-axis.
Yeah, so north is the y-axis. May I erase this?
So they'll kind of give us hints as to how to graph it.
Yes, they'll give you a hint. So if they say, like, how many degrees west of north, Sarah?
You know what would really suck?
This would be north. I would be looking for
So you have to pretend
an
north is
angle
a
here. Then you'd pretend north is 0 and find that angle. So these triangles are going to get spun all over the
What if
place.
they told us in the book, like, graph north on the x-axis? Like,
I hope they wouldn't
Wouldn't that
phrase it
suck?
that badly. Yeah,
Wouldn't
that
that
would
so
give me a
suck?
headache.
I graph it sideways and then, like, label it x and y.
All right, that would be. You could do that. You could do that. That would work. What happens to? Actually, there's a couple questions debating how much information to give you. There's a couple of questions in the homework tonight that are actually about things like what happens if you double this part of a vector, what happens if you double this part of a vector. All the hint I'm going to give you is they're asking you to think about triangles. They're questions you should know and should have thought about in geometry, but instead of saying what happens to the hypotenuse of a triangle when you change the legs, they're going to say what happens to the vector when you change the magnitude of the horizontal and vertical components. Okay, so you're going to be asked some geometry questions tonight, and I want to see how well you can think about these geometry questions. The words will be different. Legs of a triangle are now horizontal and vertical components. Hypotenuse of a triangle is now the magnitude of a vector.
Sucks.
Direction of a vector is now angles from the unit circle. Okay? This is why I wanted to start pre-calculus with trig this year, because we're going to do a lot of vector stuff. We're going to be staring at triangles. Some of you in 2 classes,
For how long?
till we can't take it anymore.
Oh my god, last year, the Holocaust unit.
All right. The homework real quick before let me just give you the homework and then.
It's on the
Before we-
website too, though.
Pardon?
It's on the website. Too.
It is on the website. The homework's online, but it is. Oh god, what page?
You had
We're moving to a different page.
Woo!
Page. I like.
Dr. Mondingo.
I like Ethan's little quieter. Yay. Okay. Now there's something that's not on the website, so you want to listen to this part. It's page 76.
Wait, so this is on the website?
Well, it's page 76, 1 through 8 is what the website says.
Yeah.
Now, on page 76, there are conceptual questions that will be heard. Stop.
It's hilarious.
Listen,
Who wants
guys,
it to be heard?
stop. Page 76, there are conceptual questions. I did not mean for you to do the conceptual questions. I wanted you to do the problems and conceptual exercises. Okay? So I want you to do the problems and conceptual exercises on page 76 because there are 2 different 1 through 8s on that page. I want you to do the second 1 through 8.
Okay.
Does that make sense?
Yes.
Okay, thank you. And cut before Ramsey can say another word.
No.